On the institute portal, you might have seen three uh, names of three faculties who would be conducting this course. The fact is going to be that I will be conducting the entire course. I used to conduct this course till 2022, and after that I have taken 2 years of gap because anyway my age is much beyond what the institute rules permit for a regular position in the faculty. However, the head of the department and many persons in the faculty of chemical engineering, they felt that it is important that this course is recorded by CDIP for the benefit of future students if people have interest in the same. That is why um, we are going to conduct this for this particular semester. The first session of this product research and development during this semester is going to be some kind of a outline of what you may expect from this course and what you should not expect from this course. Okay. So there is no disappointment at the end of this lecture series. The genesis of this particular course has two elements. Number one is really the way I am going to deal with this particular session is that I will first discuss the genesis, the historical background on the basis of which we started this particular course in 2009. I will then discuss some of the points which will emerge out of the story on Genesis and discuss with you the relevance or why one should take this particular course. We will then discuss what we are going to study during this semester, so the contents and scope of the course, and then at the end, generally the framework under which we will conduct the sessions and the evaluations, etc. The genesis of this course has two elements. I am also one of you in the sense that I am a BTech from IIT Bombay, Department of Chemical Engineering, 1970. My first job and the last job was with Hindustan Lever and Unilever, Hindustan Lever being the subsidiary of Unilever at one time. Now it is Hindustan Unilever. Dr. Kalbag was the head of the process division of the research laboratory of Unilever, which was in Andheri at that time. I joined as a research assistant in this laboratory at the advice of Dr. Kalbag. He was an extremely brilliant scientist and an extremely passionate scientist for looking beyond what his job was. So after his stint as the head of the process division, he took premature retirement and started a school for school dropouts in Pabad near Pune. So that school is known as Vijnan Ashram, and some of the contributions of Vijnan Ashram are very well recognized across Maharashtra state, and some of the curriculums of even the SSC board. So Kalbag advised me that before I proceed for any higher studies after BTech, it is important that I have at least 2 years of experience and exposure to what is industrial research. That will help me to widen my vision and also make me understand what the industrial R&D is all about, so that the academic work that I may do as part of my higher studies would be relevant to industry in longer future. So this is how I started. My first task was really to develop a process for extraction of fat from spent bleaching earth. Just to give you a small background, soaps and detergents used to be one of the important products which were manufactured and sold by Hindustan Lever in those days. And when you manufacture soap, um, you saponify oils and fats to produce the saponified fatty acids and produce soaps. But unless the oils are refined and they are bleached, the soaps are discolored, and therefore generally bleaching earth is used for clarifying the vegetable oils which are used for soap making and make them as far as possible water clear. Now this earth also carries some of the residual oil. So the filter cake contains at least about 45% of oil, and that's a big loss for the industry. And therefore, the project was to extract that um, fat from the spent bleaching earth. uh, I carried out some of the bench scale work and then developed a pilot plant, designed a pilot plant, got it built. When it was about to be ready for commissioning, at that time I had cold feet. The reason was that one of the evaporators in that particular plant was operated using steam at 10 atmosphere pressure, 150 degree centigrade temperature. And the steam wall, there was a small leak from the gland of the wall, and I was too scared to even open that particular wall. Hmm. I did not know how to open that wall. I did not have the courage. I did not have the experience to open that wall. And looking at my plight, my research laboratory assistant, his name was Joe Pereira, he just rushed forward. He put a glass cloth on the top of the wall and slowly opened the wall. Okay. Now, at that time, I felt that all my 5 years of exposure to chemical engineering in this esteemed institute, Indian Institute of Technology, I had not been exposed to a simple operation of opening a steam wall. We had models of steam wall which used to look at, we had the theory of how a globe wall or a characterized wall operates, but we had not operated a single steam wall. So this was the first kind of a realization that our education system has some lacunae which need to be plugged. From research assistant's position, as I was recruited, slowly on the basis of the work that I carried out, ultimately I took charge of the laboratory of Unilever when it was established in Bangalore in 1997. And after 5 years, I became the head, I became the vice president for the Unilever's corporate research laboratories worldwide. My job at that time, of course, changed, and it was mostly to do with recruiting extremely educated candidates, training them, mentoring them, and then ultimately leading projects with the help of their contributions. What I realized slowly that neither did I have the physical experience of opening a wall, nor these people who had received a very intense education right up to PhD and postdoc level had the necessary conceptual framework to really carry out what is expected from a PhD. I had, for example, one person who had carried out, had done PhD from Indian Institute of Science. He had gone to Caltech, did an extremely elegant work which was internally self-consistent for modeling of sand dunes under the influence of wind blowing on the sea coast. But if I ask him that this is an hypothetical new material that we must develop in order to create a different kind of a soap which has resistance towards water if it is immersed in water. At the same time, it has the necessary lathering and detergency performance that it can deliver very easily. One of his prime requirements was that if I have a hypothesis like this, I must be able to prove it with the help of already established theories, and he would not like to venture into articulating a conjecture which was not proven until then using already proven theories. This is one of the biggest, I would say, shortcomings of the people which grow up in the Indian in Indian educational systems. The reason is that right from centuries, the emphasis has been reproducing what has already been stated earlier. Okay, if you go back even 1,000, 2,000 years, then you would realize that the best academic work was reproduction of what is already introduced into some of the earlier texts. So Grantha Pramanya is considered to be the epitome of the best quality intellectual work. So articulating something which is ahead of an experiment, articulating something which is ahead of any established theories is not something that we are trained, which is the necessary requirement for structuring new knowledge. Okay, so this was the, right from the physical lack of my physical exposure to such kind of operational um, um, elements, to even the kind of intellectual exercises that we do, the limitations of those became a very worrisome, you know, in my thought process, and I was thinking that um, at some time we must be really involved in in really contributing to making a change in this particular system. So this was one part of it, my personal experience, and that how that germinated this particular idea in my mind before retiring from Unilever. The then director of IIT Bombay, Devang Khakkar, and myself, we were members of the governing council of CSMCRI, which is the Central Salt and Marine Chemicals Research Laboratory in Bhavnagar. And we used to have several discussions on this particular topic. Then in 2006, there was a FIST review meeting in the National Geophysical Laboratory in Hyderabad. At that time, he realized that I am likely to retire in 2007. So he said that instead of joining any other industry or any other industrial engagement, why don't I consider joining IIT Bombay? Because he has several concerns, and some of his concerns he expressed at that time. These concerns are that the students of IIT Bombay, I don't know about all of you, but in his perception, believe that they join IIT Bombay because it is one of the best undergraduate school. Okay, it doesn't really matter whether you do history, whether you do architecture, or whether you do biology. You must get the best possible undergraduate education to do anything in life, and that is why they join it. They don't join with an ambition to become scientists or engineers. The reason is that according to them, technology is not at all that important for the well-being of society and for improving the quality of life of society. Okay? There are many other things which are very important, but technology is not one of them. Second, leave aside society as a whole, the industry itself doesn't care about technology. Okay? Industry is more concerned about manufacturing goods at the minimum possible um, manufacturing cost and occupying white spaces so that they can maximize their profits. So technology is of no importance to them. The third thing that they believe is that whatever they learn during the coursework of the chemical engineering curriculum in IIT Bombay has no relevance to what happens in industry. So all these three concerns he articulated, and he said, with my kind of a exposure to what happens in industry, if I don't believe in these kind of beliefs, then in that case, why don't I take take an opportunity to actually articulate a course which will challenge these beliefs that the students have. So this was the reason why we started this particular course in 2009. So January 2009 was the first course that was given, and it continued for a more than about 10-12 years or so. So going back from these three concerns, let me now address all the three concerns that generally some of you may have at the back of your mind. Okay. To the first concern, I have this particular assertion, and there are three realities I am going to discuss in this, addressing the three concerns which Devang Kakkar had mentioned. The first reality, addressing the first concern, is that technological progress is the most decisive contributor of long-term non-linear improvements in quality of life of people and underpinning economic growth of society. Okay. I am an opinionated man. I have several biases, and I will discuss with those biases later, but this is certainly my first bias, and it is based on certain observations and certain studies which I have done, as well as my own experience. So let me actually elaborate this particular assertion. Before going to this, let me just narrate my own personal anecdotal experiences. Okay, I grew up in a suburb of Mumbai, Goregaon. I am 1947 born, so until about 1955 or so, at a place which I used to live in Goregaon suburbs, the suburbs of Bombay, the latrines were what can be called as bucket latrines. Okay, and the mehtars used to carry the night soil on their head. This is what I have actually seen. So the plight of those people who were carrying that kind of a night soil on their head, I have actually personally seen. More than that, this kind of latrines on the squatting position, underneath there is a pot, and there are pot worms in that, white pot worms, and they climb up. And they climb up and they start crawling around your feet where you are squatting. That used to be a horrible experience. In fact, it was so horrible that I have seen many of my friends and sometimes myself as well avoiding going to the latrine for days together. Okay, and that would lead to health problems. So from there, today we don't see such kind of the pot latrines in Mumbai. The life of those mehtars has somewhat improved, not completely improved. Today, if we count the number of deaths of people who enter the sewers, is larger than the number of deaths of soldiers on the boundary. Okay, so this also we must realize. And yet, it is far better situation than the kind of scene I have seen in my childhood. Around the same time in Goregaon area, there used to be a lot of laborers. They used to be begging. You know, they had fingers which were rotten, and it used to be a dreadful sight. I used to be extremely scared about getting infected by that particular disease. And if you look at human history, leprosy had been a kind of a curse for human beings for many thousands of years, and this was something which was so dreadful. Today you don't see laborers like this on the street. The reason is that we understand that leprosy and tuberculosis are caused by a bacteria of the same genus, and the drugs which are used for tuberculosis can be used for curing leprosy as well. And even tuberculosis, you know, it used to be called Raja Yakshma because whatever we think about Ayurveda, etc., kings used to die because of tuberculosis. That is why it used to be called Raja Yakshma. Right? So the invention of the antibiotics to these kind of bacteria has made enormous difference to the quality of life that we live. When Mount Stuart Elphinstone arrived in India, and by 1811 or so, he was going to be posted in the court of Peshwas. He first desired that he would see the country, and he had no option but to ride an elephant, and he took nearly about 6 months to go from Pune to Calcutta. Today we cross that distance in less than 2 hours. So there has been an enormous change in the quality of life during partly the period that we have grown up and also in the past. So this is something which is anecdotal. Is there something which has been a more systematic study regarding those discontinuities and those elements of progress, those innovations which have really caused a, a jump in the quality of life of people? That kind of a study was undertaken by one of my colleagues. His name was Tony Chitham. He was the chairperson of this Orion Publications. And in 2000, he commissioned this particular book, where 109 thought leaders from different sectors of economy and different sectors of social activities and human activities were invited to give their opinion about what they think as the most decisive breakthroughs in the quality of life of society. And there were people like Ogilvy, who was the advertisement guru, people like Gelman, the physicist, people like Howard Gardner, who has written the book on the various dimensions of intelligence. So Howard Gardner said invention of classical music was one of the most important inventions. Ogilvy said secularism was one of the most important inventions. Gelman said that disbelief in um, the supernatural is one of the most important inventions in the progress of human beings. But there were many other people who also said, for example, double entry bookkeeping, democracy. These were all inventions which have made our life better, no doubt about that. But out of these 109, more than 85 inventions which have been recorded there are related to science and technology. It was about, to say, for example, invention of electricity, invention of the antibiotics, invention of even anesthetics. So printing press, all these inventions, if you summarize, then you will realize that more than 85% of the inventions have been attributed to discontinuities in science and technology, which have made our life much better. Okay, so this is some kind of a qualitative work, but at the same time, it's not anecdotal by one person. It is about 109 persons of that kind of a stature, many of them Nobel laureates, who have really contributed to this particular book, and they have come up with this conclusion. Now, one objection to this kind of work by my marketing colleagues used to be, okay, all these services and products, they can make a change to the life of people only if people can afford it, only if people have money to buy it, and only if it is made available to them where they live. Okay, and therefore I said that let me look at how the GDP of different countries has progressed through history, and this is one of the very important work, well celebrated work by Angus Madison in 2007. He wrote this particular book, Contours of World Economy. Okay, and it shows how the share of different countries and or regions in the world GDP has changed over a period of time. Okay, so you can see India was on top of everybody. contributing to nearly about 35% of the total world GDP, and that was at 81. Fine. China was below that. Europe, etc., and USA, they were somewhere here at the bottom. It is after about 1700 and 1800 or so, you can see the Western Europe and USA has jumped up like this, okay, and so has really can be seen for China. And there are many works which relate this kind of a progress of Western Europe and USA and China to the kind of technological progress that they have achieved. India in AD1 was on the top, and there is a general belief that it was only because of the external aggression that the golden age of India vanished. That is not true. If you look at this actual data, right from 1 AD, nearly about up to 1000 or so, Indian productivity and the rate of innovations and inventions have been diminishing, and therefore its share in the world economy has been dropping. What is the origin of this particular drop? There are many people like Bhalchandra Udgavkar, who was the head of the nuclear science department of TIFR, people like Arnold Toynbee, people like Joseph Needham have written extensively on the causes of this particular decline of India, and we may have an opportunity to discuss even the ancient history of in the domain of science of India and why this kind of a decline took place. In case of China, again, it was a civilization which has given us several inventions. The printing press, the gunpowder, the compass, so many different inventions have come. Even the spinning of cotton, all those inventions have come from China. There is a concept called the high level equilibrium stagnation, and because of which the social conditions in China, they at one time became adverse for new scientific and technological inquiries, and therefore it stagnated. But later on, of course, it again, after it came down here, after the revolution in China, suddenly they have again picked up. This is the kind of a progress that they have achieved. Now, this is as far as the GDP is concerned. Now, there are other several factors people may argue. For example, imperialism has been one of the causes of our downfall. Education is another thing, but that again is correlated with the cause why Indian productivity dropped during this period, and the new inventions in the physical world diminish during this particular period. Because if you look at the literacy percentage of India, okay, in 1905 it used to be only 5%, okay, whereas in Europe and the literacy rate had gone to something like about 60% around 1900. So the rise of Europe has also something to do with, apart from technology, the literacy rate and the spread of education, which was denied to a large portion of population in India in the Indian context. Okay, so there are several factors. So how do we really then really isolate the contribution of technology in the growth of economy in such kind of a scenario, and with such kind of several factors which interfere with these kind of empirical observations? We can look at the models of economic growth starting from Adam Smith. Do you have economics as one of the options for your? So Adam Smith's contributions you have studied? No, not yet.
Yes,
Huh?
we did a basic course on economics. I think it was in the first part.
So what was contribution of Adam Smith? Principal contribution?
The Wealth of Nations.
Yes.
The book, and then the initial theoretical.
No, but what were the two concepts that he introduced which were critical for growth of economy.
One was comparative advantage.
No, that is Ricardo.
Oh,
Okay, so one was division of labor. So you can divide, the work which is being done for one particular object, one particular artifact into its constitutive elements, and you divide that labor. And second is also free market economy. Okay, so these were the contributions of Adam Smith. The second person noteworthy is Karl Marx. His contribution uh, somebody can identify quickly. Simple, one word. No, but in economics. His contribution really was that capital formation is a very important factor in the growth of an economy. So accumulated capital is the source of accumulated capital is discusses the much of the Marxian theory. But as far as economics is concerned, capital accumulation is the factor which is most important for finding out a correlation with the GDP. The next is Harold Domar. He added his element to that, and he said that the source of capital accumulation is the savings by people. So income minus expenditure leads to net saving, and higher the rate of saving, higher is the rate of capital accumulation. So that is the Harold Domar contribution. And so therefore the neoclassical view is that if this is GDP, K is the accumulated capital, alpha happens to be the elasticity of GDP with respect to capital, okay, and L is the labor force. So you divide this whole thing by L, then you get the GDP per capita, which is proportional to this. Okay, this is the neoclassical theory. What is the meaning of alpha? You have any idea?
Response to how GDP changes with respect to
Yeah, but any say for example 1% increase in capital will lead to how much increase in GDP? How much? The expression gives you a straightforward answer. Huh? If capital increases by 1%, the GDP increases by alpha percent. Huh? When you look at a mathematical expression, you must actually try to get insights from that mathematical expression. Don't leave it at some kind of a formula that you will use later. Here this gives you a direct insight that 1% increase in K is going to lead to 1 alpha percent increase in Y. Just calculate that if you want. Fine. So this is something which was up to the neoclassical view. A major contribution to this theory has come from Robert Solow. Robert Solow joined MIT in 1949. He carried out his research work on the capital accumulation and the GDP growth of USA from 1905 to 1949. And he came up with this particular expression. Okay. In this expression, he introduced this particular factor. In the previous chart, by mistake, I have not eliminated that A. So I just brushed aside. But this A is not there in the neoclassical theory. Fine. So this A, he said, is a multifactorial productivity embodying effect of technological progress. And his observations were that new capital is always more productive than old capital. Okay. If there is no technological progress and simply capital accumulates, the economy in fact stagnates. So these are the very important observations that he made, and he was rewarded with Nobel Prize in 1987. You have heard of Robert Solow? Important man. He had 4 students who received their PhD, like Joseph Stiglitz. Latest was Romer. Romer's PhD is an extension of this particular expression, where he said A is not exogenous. It is not the academic work which is only contributing to A. It is not exogenous to the economy as such, but the reinvestment of capital into R&D by industry also contributes to A. So therefore, that is the improvement which Romer did in 2018. Okay, so this is a very important relationship, and if you look at how Indian economy has grown, you will also see the kind of an exponential growth. We had such meager capital in 1947 because we were completely impoverished by the British imperial powers, and so therefore economy always grows in that kind of an exponential manner, and it is not though so great that in recent times the economy rate of growth is much bigger than in 1947. But that aside, so ultimately, technological invention is the most decisive contributor of non-linear economic growth, and jumps in quality of life in a society is the first assertion that I wanted to really submit to you. The second assertion, okay, the second reality, technological invention is the most decisive long-term differentiator of products and even market innovations. Technology matters in industry. Okay, I don't know how much you are familiar with the market wars between P&G and Unilever. Okay, at one time, Unilever was the market leader of laundry soaps in USA. Lux Flakes were considered to be the most premium products for washing laundry clothes. The P&G was nowhere close to Unilever at that time. One person, rather, a group of persons in P&G at one time speculated. This was a result of their visit to Germany during the wartime, when they saw a surface active agent called Igepon, which was developed by IG Farben, which was extracted from bile, okay, and it was used as a wetting agent at that time. So P&G people, the R&D team, which had gone for scouting different ideas in Germany, they identified Igepon as one of the potential candidates for making new kinds of laundry soaps, and therefore brought lot of Igepon, worked on it for nearly about 10 years. They worked on it, got frustrated, and the whole idea was abandoned. Okay. Then came one person. He started looking at what is the problem with Igepon, and then he realized that one of the problems is that if you have hard water, just as soap also forms scum, the surface active agent synthetic does not form a scum. But in hard water, you do not get the kind of performance that you expect. Okay, so P&G were experimenting with soda ash as a builder. Now, soda ash, when it combines with calcium and magnesium in hard water, it deposits calcium carbonate and magnesium carbonate on the clothes. And after several such kind of studies, it was decided that this work has to be stopped. It will not go forward. There was one research scientist, Dick Byron, in P&G, who still continued with that work covertly. It was fortunate for him that in 1936 onwards, a new research head came in charge of the research laboratory of P&G, and then Dick Byron had the courage to disclose what he was doing. And he, in his experiments, studied all different kinds of builders. Ultimately, he came up with a pyrophosphate and polyphosphate, which can sequester calcium and magnesium, and therefore it will not form a deposit on the clothes. Now, because this work was being done covertly by him, nobody had a courage to actually present it to the higher board and the marketing people. But then somehow the news leaked, and then they carried out the work in the pilot plant, produced the first sample of Tide, and then rest is history. Because once Tide was launched, Unilever was completely washed out from the American market. Now Unilever does not have slightest presence in the laundry market of USA. So it was not a different kind of a product. It was a new kind of product, okay, and which not only caused the product innovation, but it caused what can be called as a market innovation. Hmm. So this is something which is a story of P&G and Unilever's rivalry. It's a very exciting story, and this particular book, which is published by the Harvard Business School Press, Rising Tide by D. Dyer, etc., it's something which is worth reading. I think we have a copy in our library. I have a personal copy. Anybody wants to read that, we can take an extract at least of this particular chapter, and then you can read it. Right? So this is the second assertion which I wanted to make, that technology does matter even for individual industry and individual companies. The third reality, it is about character of successful innovators. It is not about technology, but the innovators. And it has got, again, the third reality has three elements. Successful innovators who invent technology embedded new breakthrough products display scholarship and mastery over pre-existing knowledge, expertise and toolkits. There is a general I would say, belief among people who join the schools of management that it doesn't really matter whether your background is a historian or a musician or anything else. If you have the innate intelligence, then without knowing the subject matter, you can simply brainstorm on a blackboard and come up with radical breakthrough ideas. This is all bogus. It doesn't really work. You will see that all really genuine breakthrough technologies arise out of deep scholarship and mastery over pre-existing knowledge and expertise and toolkits. So the misconception many people carry as a result of this kind of an onslaught by the marketing and financial gurus, it's something you should be cautious about. The second element of this particular third reality is you need unique competencies while operationalizing these particular skills. So you have to transcend what you learn in a textbook in order to really be operationally successful. And you will find, and I have found many times, people who are the first rankers in a university are not necessarily the best inventors. Okay, there could be somebody else who has got a breadth of different kinds of exposures to different constituencies of life, who come up with an extremely novel and new idea very often. So there are different kind of competencies which we will be discussing as a part of this particular course, and they can be categorized into different buckets. One is intellectual power, which again comprises of three components, which is the clarity of purpose, objective analytical power, and practical creativity. Entrepreneurial spirit is another kind of a competency. Entrepreneurial spirit is about having bias for action and being a problem solver rather than a problem analyzer and articulator. The ability to self-renew oneself with newer and newer kind of challenges is another important ability. So several such kind of competencies are there, which are going to be part of our study with concrete examples. So unique competencies, and one of these competencies is the most important, is the capability of constructing new knowledge, transcending textbooks, employing hypothetico-deductive approach of science required for discovery of new laws of nature. So at this level of breakthrough technology inventions, the kind of approach you would see most often successful is the same which is required for discovery of new laws of nature. Okay, and this is what I call as hypothetico-deductive approach. And the first example which I gave you about one of my colleagues who happened to be a postdoc from Caltech, unfortunately lacked this approach completely. So construction of new knowledge has taken place in science only when somebody ventures beyond what is already written in the textbooks and makes a conjecture ahead of experimentation or ahead of another theory. Okay, so this is a very important ability, and in the kind of exercises that we will be carrying out, we will try to see whether we can imbibe this particular competency in us. So this is going to be a very important component of our practical work. Fine. Now, this is what I have really discussed, which is about my biases. You may wonder, this fellow is giving some sermons which are read in some textbook somewhere or somebody else's work. And so, what is the kind of a, you know, what justification he has got to make this kind of an assertions. So I just thought that I would share with you some of the inventions with which I was associated and mostly led by me, so that you feel comfortable that there is at least some element of uh, wisdom in allowing me to make the assertions which I have made. For example, this is silica gel and this is close-up toothpaste, and close-up toothpaste used to be made at one time by importing silica gels from Crossfields, which was a which Crossfield Chemicals is situated in UK. There are two kinds of silica gels which are required for making close-up toothpaste. One kind of a silica gel is an abrasive silica gel, which has the necessary hardness which is lower than that of the dentin of teeth, but higher than the plaque which grows on teeth, okay, so that it can work as a polishing agent for toothpaste. And the second is a absorbent silica gel which has a very high pore volume, and the technology was available with only Crossfields at that time. Although the Hindustan Lever was a subsidiary of Unilever, Crossfield refused to pass on that technology to us because they used to export those kind of silica gels to other companies of Unilever worldwide. So it was an imperative that we develop our own technology, and we developed that technology and implemented it at Taloja. This is a plant which is a simulated moving bed chromatography plant. One of the challenges we had when the research laboratory of Hindustan Lever was founded was to find out substitutes for vegetable oils which were edible in nature using minor oils which were not edible. And for example, at one time groundnut oil used to be extensively used for making soaps, but since groundnut oil is useful as an edible ingredient, it was going to be unlikely to be available for making soaps in long future, and therefore Hindustan Lever invested quite a lot of research in making minor oils suitable for manufacturing soaps. And one such effort was to make use of sal fat for manufacture of soaps. Sal is Shorea robusta, grown in peninsular India, and this particular fat, the way it is harvested leads to its degradation during storage. And if we can remove the degraded components, the only way to do that was by chromatography. People were successfully doing that kind of a refining in laboratory, but doing that on industrial scale was a big challenge. In fact, Unilever's laboratory in Hamburg set up a pilot plant to refine sulfate, which was imported from India, and they miserably failed, and therefore they abandoned that particular idea. In fact, Vero Bake, I don't know whether you have heard of his name, just as Bird Stewart Light Foods transport phenomena is very famous in Europe, in American and the Asian countries. In Europe, Vero Bake's transport phenomena book is considered to be one of these standards. Okay, Vero Bake was the head of flooding and laboratory of Unilever. He said that chromatography will not work. Okay, we took that challenge because we felt that that is the only way to go ahead and manufacture refined sulfate which is suitable for making cocoa butter equivalents, and we developed that particular process, scaled it up. This was a 3-meter diameter chromatographic column, simulated moving bed. In 1983, this was probably the first simulated moving bed for such kind of an operation. Later on, people like Ruthvan did lot of work on simulated moving bed. He visited us also, saw this operation, and he was taken aback that much before what he did in academic circles, actually the plant was operational in Taloja. Okay, so this is something. This is my figure at that time in 1982. So there are several such kind of projects. This is a intermesh twin screw extruder, and the simulation of this has appeared in the AICHE journal. This is vacuum super insulated containers for distribution of ice cream, and this was one technology with which we could distribute ice cream in the hottest summer of Bikaner. The person here is Aparna Konduri, a young chemical engineer who had joined us, and he worked on this particular problem, and later on he also took that the actual reality test of that particular device in the marketplace. So several such kind of things. I must consider myself extremely fortunate to join Hindustan Lever at a time when the industrial policy was such that all multinational companies, if they wanted to stay in India, they were compelled to do something in the technology intensive industries. That was the only reason why Hindustan Lever entered this diammonium phosphate technology. Okay, so the multinational companies which were willing to actually take up that kind of a challenge did thrive even during that period in India and contributed to its economy. And fortunately, many of my colleagues and myself, we were fortunate to join Hindustan Lever in that era. Okay, so this is some kind of a background which I wanted to share with you. So, having dealt with the three concerns which the director of IIT Bombay had expressed to myself, let me now turn to the content of this course. Okay, what you may gain from this course. Fine. One is the familiarization of components of the process for product research and development. This is the structured approach which anybody takes for the process or product development. Identification of consumer and customer needs, translation of needs into R&D briefs, candidate idea generation, shortlisting and selection of idea, and execution of the idea. And there are various smaller and smaller techniques to optimize decision process in all these steps. So we'll discuss this particular aspect of the process and product research development. The thrust of the course, as I said, is how to make inventions happen. So therefore, this is going to be something useful and important to you. The second thing is the identification of determinants of performance of an R&D scientist. So if you take a performance here, there are three dimensions which contribute towards performance of any one of you who would like to get into R&D. And really speaking, I have just identified some of the skills, etc., which are relevant to R&D. but now this kind of a framework is used for performance development in any sector of economy. Okay, so one is the home-based skills and the generic skills and expertise which you acquire as part of your coursework here. So these are generic skills. Then domain knowledge and expertise, which is usually you acquire when you join an industry. For example, I mentioned to you about sulfat and soap, etc. Now that is something that you will not be acquiring as part of your curriculum here, because you would look at more generic home-based skills like mathematics, thermodynamics, physics, chemistry, etc. Generic skills like, say for example, the critical path method for project management. So this is something which can be called as home-based skills, because they are so generic that you will apply it for irrespective of the project or the kind of work that you will do. Whereas domain knowledge and expertise will be acquired on the job. When you go for any interview, nobody expects you to really be experts in domain knowledge and expertise, but you need to be certainly at home with the home-based skills. And third dimension is the competencies, which I mentioned to you, which is the intellectual power, entrepreneurial spirit, the external orientation, etc., etc. So we will go into more details of this particular dimension. Honing of some home-based skills, thermodynamics of phase equilibrium of highly non-ideal systems, multi-component and multi-phase systems, and transport phenomena. The reason is that, as I mentioned to you earlier, that creating technology embedded products does require deep insights, both breadth and depth in a person, in order to come up with new ideas and make them happen. Okay. So generally the schools of management believe that breadth of vision and depth of insight cannot reside in one person. I do not believe in that. You don't believe in that, because only when the two reside in one single person that the person can become really creative. Okay. So generally the approach of a MBA from a school of management would be that, okay, I am going to provide only breadth of vision. I will hire some people to do the detailed work who may provide the depth of insight, which doesn't happen by in any breakthrough kind of a technology development. So thermodynamics of phase equilibrium of highly non-ideal system is something that we will brush up, okay, because this is going to be a very important component of the examples that we will take for illustrating the hypothetico-deductive approach of designing and developing new products. So thermodynamics will play an important role in the or will have an important place in the kind of work that we do, and it will be part of an assessment. I will do my best to actually do the hand holding for all of you, but you must have interest in thermodynamics and you must be prepared to really spend time and energy to hone your skills in that. Fine. Transport phenomena we may touch upon. So the thrust of the course is how to make inventions happen and technology embedded inventions happen, and in that background the such kind of honing of home-based skills is going to be a very important part before we start doing any kind of a practical creativity exercises. Introduction to hypothetical deductive approaches of science and technology. So whatever I discussed earlier, the way we went about inventing some of these, we will discuss as part of it. We will pick up some of these as examples for our own exercises, etc. Chocolate is something which is very easy to pick up. This is the anti-icing liquids. Ice cream also, DAP also will take. This I may not be able to touch upon. This is a water-based clinical thermometer. Okay. We had a factory in Kodaikanal, it became extremely notorious because of the contamination of mercury in the neighborhood which it caused. The company was aware of this particular potential risk and danger, and therefore they had commissioned the research laboratory to develop a thermometric fluid which will be a substitute for mercury. And it was an extremely challenging project, and that challenging project we actually nearly completed. I in fact have a sample of a clinical thermometer which measures, which is a maximum registration thermometer, and such kind of thermometers are the cheapest maximum registration thermometers. So if you see this kind of thermometers, you see the maximum temperature of your body, you shake it, and then it again gets reset. Now the general ordinary maximum registration thermometers have a float. You need to use a magnet to actually bring it back, etc. And it is the interfacial science of this particular neck which is really very important, and the way the thermometer fluid is designed and the way the internal surface of this thermometer is lined up, it's something which results into this. We have a patent for this. It so happened that before it was implemented, the factory was closed, patent was not utilized, and then the company tried to actually sell it to a Chinese company, but that also did not go forward. So it's a patent which is open. Anybody wants to get into that area, it can be used. It is already out of the time limit now. Okay. So anyway, so we will have some of this, but we will not be able to discuss this in much detail because it will have to go into more details of interfacial science. Okay. In addition to that, we will have introduction to other important skills and competencies and topics. For example, the PERT and CPM techniques of project management, which I feel at least the elements of that must be imbibed in our day-to-day working. And it is not necessarily for only projects. Even if you are planning a outing, even if you are planning a trek somewhere, this technique comes to your help, rescue, and it is a very important technique, and it helps you to really identify resources which can be active in parallel to each other, so that the time required for achieving the end result is reduced. So this is a very important technique that we will learn. We may brush upon the patenting laws and the criteria for something to be patent worthy. Then we will also touch upon, I will show you a particular film which I personally found extremely useful. It is Eye of the Beholder, which was shown to us in our Hindustan Liver days. I had lot of trouble to really get that particular film for our course here. First of all, to find out the original source and then get it purchased here. The chemical engineering department could not buy that particular film because it has something to do with social psychology, and therefore Professor Jha helped me from our management from SOM to buy this particular film. So we have that particular film. We'll have one session on this Eye of the Beholder. Fine. Other topics to be discussed would be, for example, what is the difference between research and product development? What is the difference between academic research and the industrial research, etc.? What are the criteria? It's something that we will discuss. So this is the list of other things that we will touch upon. Sources of inspiration for new product development. For example, there are products which are market driven. There are products which are discovery driven. Okay. One very simple and straightforward example is Freon. Freon was market driven because Mijli was given a task to invent Freon, which is non-toxic, non-flammable, and therefore one of the best refrigerant. Whereas working on Freon, the people discovered the properties of polymerized Freon, and that gave birth to Teflon, and it had lot of resistance before Teflon became popular. So therefore, those examples will touch upon. So sources of inspiration for new product, different R&D processes followed by market pull and technology push, etc. Four-stage career development model for R&D is also a very important one. So when you join an industry, you would join one of those stages, and as you rise in those 4 stages, the nature of your responsibilities and expectations change. People are not familiar with this particular model, so we will touch upon that, as well as academic research and industrial product R&D. Fine. This is the reference material. In addition to that, while we discuss, there could be other many books which I will just display or give references. You may like to go through them as well. But Ed Kussler's book on chemical product design from Cambridge University Press, Ulrich and Eppinger's book on the product design and development, um, uh, James V. This is a very important book, Product Engineering, Molecular Structure and Properties. Peter Medawer's Induction and Intuition in Scientific Thought and Advice to Young Scientists is something which is worth reading by everybody. I don't know how many of you have heard of Peter Medawer. Okay, so Advice to Young Scientists is a gem of a book, and it conceptualizes the scientific methodology and the hypothetical-deductive approach which I have been talking about. So I will be giving the lecture notes. Department seminars and institute lectures is something which you should be attending, is my personal submission to you. In the past, I have picked up examples from such kind of lectures and elaborated in our course as well as in the examination. So it is important that you attend the different seminars, because that is the only way you will improve your breadth of vision. Otherwise, you will go into a narrow tunnel into what you are doing on that particular day on the bench. We'll have some hands-on exercises. So this is generally the kind of work that we'll be doing. Let me see. Okay, evaluation, no mid-semester examination, 2 tests carrying 40 marks, that is 20 into 2. End semester examination is 60 marks. In addition, periodic assignments, quizzes, participation in class, up to 15 bonus marks I give, because this adds up to 100. So this is 115 plus attendance, 5 bonus marks, so 120, and then it is rationalized to 100 marks. Possibility of absence leading to deregistration, and less than 80% attendance leads to DX grade. Okay, I used to somewhat overlook the attendance at one time, but then I realized that you will not find the course material in a integrated manner in any book, and therefore such students which really do not attend, ultimately I have the unpleasant job of really giving them FR. So I don't like that job. So that is one of the reasons why I would advise just keep attending. That is one. So this is code of conduct. Total presence essential, physical, intellectual and emotional. Okay, because that is the only way that you will internalize what we are discussing here. Cell phones off, no rings, no messages, no games, no preparation for quiz on the next day, and no sleeping during the session, even keeping your eyes open. I have seen some of you do develop a technology of keeping eyes open and sleeping, but please don't do that. So this is the updated enrollment criteria. Upper cap for numbers is there, then diversity. One of the reasons why this is there is that very often setting papers and evaluating them is a huge task, and if the number exceeds a reasonable value, then it becomes quite a drudgery. Um, we have encouraged diversity in the class from second year right up to PhD. Whoever is interested can join, and across the different departments. Um, Preference for pre-registered students, and ultimately we have to do sorting by CPI. So this is how we have, Rochesh has in fact done this by kind of work and ultimately enlisted you. So this is about a benchmarking test on thermodynamics, which I used to give in the past, because so the second session used to be on thermodynamic test. Okay. The reason was that then early enough, all the students get an idea about the kind of thermodynamics that we will be dealing with, fine, and therefore they can make their appropriate choices early enough. That was the reason we used to give. But then, I find that losing 1 or 2 sessions like this uh, puts makes it difficult to complete all the coursework. So I will not be giving this particular test, but I will just illustrate to you the kind of test it was. So this is, for example, identify errors in 2-component phase diagrams at constant pressure and explain why. So if you are familiar with the rules of phase diagram and the kind of, so this is very important. You will find lot of phase diagrams which you also keep on using without being aware that thermodynamically they are inconsistent. Okay, so developing an ability to make a judgment about the validity of a phase diagram is a very important ability. So when we go across through different parts of our thermodynamics, this is an ability that you will imbibe, is my hope and expectation. This is another diagram. It is from a standard textbook and there is an error in this. Okay. So when you read, I keep on telling people that even research papers published in the most esteemed journals, if you don't find a single error in that, then you have not carefully read that paper. Okay. So this is a phase diagram which is in a very esteemed, rather I would say standard textbook, and there is a obvious error in this particular diagram. So I had asked people to find out this particular error. This is a standard example, methanol and water. So this is very, very structured, being ideal solution. If you have learnt solution thermodynamics, then developing these Tx diagrams and Yx diagrams is not difficult at all. But the next one, if you read, you may feel extremely daunting. That I have asked you people to generate a Tx diagram for hexane and water system, the two liquids being almost immiscible with each other. Okay, you feel that it is something which is extremely difficult, but we will see during the course that this is simpler than predicting the Yx and Tx diagram of methanol water. Okay, so we'll do that as well. So this is another example which I wanted to show, that very often we know more than what we know. Okay, and this is one such example. Okay, so we have come to an end. If you have any questions, please go ahead. It is 18:45. No questions at all? No concerns also? बोलो ना.
I don't have a background in chemical engineering, so
Yeah.
should I use any references to back up?
When we come to chemical thermodynamics, okay, I will give you the necessary references, and certainly I'm going to teach thermodynamics, not the axiometric way of thermodynamics which is taught in normal coursework. Okay, um, Lewis and Randall's book on thermodynamics is, I personally see as a role model of a book. The reason is that it presents how thermodynamics developed as an empirical science, and in a hypothetical deductive manner, people really articulated the different laws of nature that you see in thermodynamics. So he actually describes it like building a cathedral. People built a wall, it collapsed, then built another wall, it was going to collapse, so they gave a scaffolding to that. So that is how thermodynamics has developed. So we will look at the way we really learn thermodynamics is that way. Fine. So if you are really interested in this particular topic, it should not be a barrier to you.
My aspirations from chemical courses in general is to develop something later on.
Yeah.
I have entrepreneurial aspirations later on in my life as well. So
Yeah.
that is the reason I took these kind of courses.
Sure. Huh? So please put in extra efforts. It should be all right. Fine. Anything else? How do you register your attendance? On the attendance sheet, is it? Okay. In during the first couple of years of the coursework, because the students used to be up to 35, 40 or so, I used to take roll call, and that used to help me to remember names. Unfortunately, with a large number like this, and my age is also catching up with me, so I remember the names of all my schoolmates, but I don't remember a person whom I met yesterday. So please pardon me if if you experience that kind of an encounter with me, but we will try to do something about it. Right? So if there is no question, we'll meet on Friday. Huh? Okay, thanks.